Good morning, students. I'm taking a lecture of design of structures, and the chapter is, I think it's chapter 4, philosophy of limit state design for steel, right? So, before we start this chapter, there are various topics like bolted connection, tension member, compression member, welded connections. So, what are this type of connection? And these basically are this steel members, right? So, we start with this question that what is this meaning of steel structure? A structure which is made from organized combination of structural steel members designed to carry loads and provide adequate rigidity, right? So steel structures involves a substructure or members in a building made from structural steel, right? So these three figures, which is a major example of this steel structure, which is trusses or bridges or some steel buildings, right? So these figures are shown an example for a steel structure. Next is elements in a steel structure. So there are many types of or there are number of steel members here. So first, what is it is based on the shape, right? So there is a I section which have flange and wave, and next is H section. Going to the further, there is a L section. Is uh, sh- L is also called angle section, right? Then next is T section, which is in square, also a squared steel member, round steel member, right? It's a hollow or solid, right? So these all steel members is physically distinguishable, right? So part of structure with independent structural function. For example, this member elements and cables, beams, sections. These all members are used in different types of beam, section, trusses, bridges, right? So what are going to the further? What are these main advantage of this steel structure? So the first thing this you have have your mind. So first is what are the advantage is a high strength, right? So first is a high strength. So second is a high ratio of strength to weight. So steel offers much better compressive and tensile strength than concrete, obviously. Then the ratio of the strength to weight, the strength per unit weight. It has some excellent ductility and seismic resistance, right? Uh, it withstand extensive deformation without failure even under high tensile stresses, right? Because of this meaning is it has some high ductility which enables it to withstand extensive deformation without failure. So it is more safer against sudden loads and overloadings, right? So next is elasticity and uniformity of material. The next is the predictability of properties and close to design assumption. And as of fabrications and speed of erection, right? So prefabrication, it will be a prefabrication or and also demountability. So connections using this type of members, which is welding, bolting, riveting, can be done easily, right? So structural steel is generally used in a load bearing frames in buildings, in truss members and also bridges. Unlike masonry or reinforced concrete, steel can be easily recycled. It is environment friendly, right? So these are the advantages of the steel in this structure. Now the specific strength, it's a material strength which is divided by its density, and it is also known as the strength to weight ratio or strength by weight ratio in fiber or textile applications, right? So specific tensile strength of the various materials like magnesium, aluminum, stainless steel, titanium is mentioned in this table. So we going further. The magnesium strength is 275 megapascal. Aluminium has a strength of 600 megapascal. Stainless steel has a 2000 megapascal strength, and last titanium has a 1300 megapascal strength. And going to the further, this different types of material have different strength, density, specific strength, and breaking length, right? So the steel structure facilitates ease of fabrication and faster erection of the structure. Bolts and weldings are employed for this joining. Uh, Generally, the two members are joined by different types of connections. In that case, they are using bolt connections or welding connections. As you can see this in figure, these all are connected by a bolted connections, right? So going to the further, what are the disadvantage of using steel in a structure? So first is the susceptibility to corrosion. So it requires a corrosion protection because it's made from the structure is made from steel, and because of steel, in contact with this water, it will be start this process of corrosion, right? So it requires some protection or some type of layers, right? Next is maintenance cost or thin wall structures. Next is loss of strength at elevated temperature. The next is fireproofing cost, and the another one is susceptibility to buckling, and the fatigue and brittle fracture. Means that it requires some fire protection. This because the strength reduces at higher temperature. As the increase in the temperature, the strength of the steel is also decreases, right? In steel building, cladding and dividing walls are made up of masonry and other materials. That are the main disadvantage of this structural steel, right? Welding, tightening of high strength friction grip bolt, which is known as HSFG, requires proper drilling. In many cases, cost of steel structures works out to be more than the concrete structures because it is made by steel, and steel is cost more than the concrete, right? So, at the end, tolerance specified for the steel fabrication and erections are small compared to this RCC structure. So, these are the advantages and disadvantages of using steel in the structure compared to this concrete structure, right? Where and when use these steel structures? So starting with this first, long span structures, multi-story and high-rise buildings of heavy duty plants where we can use the steel structures, tower and mast structures where these steel structures are needed, portal frames, bridges. Portal frame bridges are the main or large structures which is not made only not using these concrete structures, but definitely used in steel structures, right? Some infrastructures, deployable structures, generalized structures, it means that mechanical structure mostly. uh, so these all are these structures where we can use this steel. Now going to the further, what are the limit states? So the limit states are acceptable limits for the safety and serviceability requirements of the structure before exact failure occurs, right? So the design of the structures by this method, this thus ensures that they will not reach limit states and will not become unfit for the use of which they are intended. So it is worth for mentioning that structures will not just fail or collapse by violating or exceeding this limit state, but the failure therefore implies that clearly defines limit state of structural usefulness has been exceeded, right? So it is for the safety and serviceability requirement of the structures before the failures occurs. These are exactly known as the limit states. I think you understand that. Now going to the further, how many limit states are there? So limit states are divided into these two parts. First is the limit state of collapse, and the another one is the limit state of serviceability, right? So in a limit state of collapse, it deals with the strength and stability under maximum load, strength and stability of the structures under maximum design load. And in the limit of serviceability, it deals with the deflection and cracking under service load. So the durability under the working environment, stability, fire resistance, etc., etc. So we focus on this limit state of collapse. uh, it includes loss of equilibrium of the structures and also include loss of the stability of the structure, also the fail by excessive deformation or the rupture, fracture due to fatigue, and the brittle fracture. So ultimate limit states are those catastrophic states which require a larger reliability in order to reduce the probability of its occurrence to a very low level, right? So these are those associated with these failures under the action of probable and most favorable combination of the loads of the structures. So using partial safety factors, we may endanger the safety of life and the property. Now discussing about this limit of serviceability, so it includes deformations and deflections, vibrations, repairable damage or cracks due to fatigue, corrosions and durability, and fire. So this limit state of serviceability is related to the satisfactorily performance of the structure at working load, right? So these limit states deal with discomfort to occupancy or malfunctions caused by excessive deformations, vibrations or corrosions, etc., right? So these are the two types of limit state, which is limit state of collapse and limit state of serviceability. So here we end this lecture. uh, Before we go to the further, so if you have any questions in this lecture, so let me know, so I can solve your all questions, right? So we stop this lecture here.